in previous class, you have studied about this type of the figure. Okay. What we call for that type of the figure? It's a cube. Now, let me do one thing. I'll extend the one side. I'll extend one more side. Even I'll extend this side also. This let me call as x-axis. This let me call as y-axis. This let me call as z-axis. X-axis, y-axis and z-axis. Are you imagining 3D figure now, my dear students? I'll consider this is the origin. Origin of 0, 0, 0. See, if the point is 2 dimensions, we need 2 coordinates to represent. For example, graph you consider. You used to, if you want to name this point, we have to go in x-axis, we have to go in y-axis, then we will get one point called 2, 3. But when you go for 3-dimensional figure, you need to mention in 3 coordinates. Right? That only here origin. In x-axis also at the origin, x-axis also 0, y-axis also 0, z-axis also 0. Therefore, I'll consider this as a 0, 0, 0. Now, one more point arises to me. Here you have to understand very carefully. Where I am joining, you understand. Let me take one point called P. Let me take a point called P. I think you can see this. Point called P I am taking here. Now, let me join O to P. See, this coordinate which will represent us, we don't know exactly. Therefore, we shall think that in x-axis, we have to go. Look at here. From the, if I consider this is the x-axis, from x-axis, I have to go x distance. From y-axis, I have to go y distance. From z-axis, I have to go a z distance. Then I'll get this point, we shall consider like this. So, this point P is called, we call that as a very important concept, my dear students. That is called by the name position vector. What we call for that? We call that as a position vector. See how we can define this? Position vector of a point P. Position vector of a point P is x, y, z is a vector. It is a vector. Will you agree or not? It is a vector. Will you agree or not? This OP is a vector. It is a vector whose initial point is 0, 0, 0, and terminal point is what is terminal point, guys? Terminal point is x, y, z. Terminal point is x, y, z. Position vector P. Position vector P of point P. How we will represent this? Do you know? Point P is vector OP. Position vector of a point P is given by vector OP. So here generally we will consider that as, my dear students, we call that as a R. Vector R. Position vector will be, generally we will call by the name vector R. That is equal to vector OP. Vector OP only will be called by the name vector R. That is equal to, see, this is directly I'll give here that how we can measure the distance is by distance formula, by simplifying the distance formula, x square plus y square plus z square we can use to find the distance of the position vector. Direction cosines and direction ratios. We shall understand here very carefully. Direction ratios, direction cosines and direction ratios we shall go. Same thing will come, guys. Here also same thing will come. So there will be 3 points. So here if I extend, this will be z axis, x axis, this will be y axis, this will be a position vector p, x comma y comma z, whatever it may be. Let us join this. This x axis forms one angle with p vector, that means position vector. Understand here? If it is not clear, I'll tell you once again, don't worry. X forms one angle with p, that we shall call as a angle alpha. That we shall call as a angle alpha. Now y axis forms angle, even y axis forms angle with p. I'll come to that, this one I'll come back, then you will get it. See, this we shall call as angle beta. Z forms angle with position vector. Z forms angle with position vector. That we can call it as alpha, beta, that we shall call as a gamma. If you see here, this is one axis, x axis. This is y axis. This one is z axis. This is this yellow cap you can see, no? That you consider as a position vector p. Now see, you can observe here, there is a formation of 3 angles. Look at here, that first white pen is forming one angle with this yellow pen, that we called as alpha. This, if I consider x axis is forming one angle here. Can you see? So this is called by the name alpha. This imagination should go to your mind. Then if I go for y axis, see, y axis, there is also y axis is forming one angle with, you can see, I think properly. See, it is called by the name beta. See, here z axis forms one angle. You can see here, z axis forms one angle here. See, totally you can see there is a 3 angular formation with the position vector. That angles is called by the name direction angles. Here we call alpha, beta, gamma, are called position direction angles. Now you understand. X axis forms alpha. This is y axis. Y axis forms beta with position vector. Y axis forms beta with position vector. Next, z axis forms angle gamma with position vector R. I think this much is clear to you. See here, little bit big only I'll draw. Observe carefully. Okay, this is axis. This is also axis. This is also axis. Now, this is a position vector. Which one? This is 0, 0, 0 is position vector. This is P of x, y, z is a position vector. Once again, I'll tell you. See, this is origin. This is x axis. So this line, I'm speaking about this line. This is origin. This is x axis. This is origin. This is x axis. Now I have joined this line. Which line? PA. Don't think inside. It is this space. In this space, I have joined this line. So now what happens? This forms 90 degree. Here you see. This figure only small I will draw. See that what I said I will draw that only. See here. This will become 90 degree. This line, what forms here inside, that will become 90 degree. See here now. This, if I consider this is a line, okay, this is a line. It forms 90 degree. This here. This is the line. This is the middle line which passes through diagonally. So this forms 90 degree. That figure only I'll draw here. This is the point A. OAP. I'll call it a OAP. Okay, na? This is the point A. This is the point P. Point P is here. So this is O, origin. See here now, angle it makes, they at the point A, there will be a formation of 90 degree. There is a formation of 90 degree. Is it clear to you now? Anyhow, position vector we called by the name R, vector R. Correct? Now already I said we called position vector as a R. We said already. Let me go for cosines means already you know well. We have to go for cos. See in this figure, we can write this position. We can write this position as OAP. I have drawn separately OAP. So at A there will be formation of angle 90 degree. Okay, I think this much is clear. Now we have to find cosines. Cosines means what? We shall find cos of alpha. We shall find cos of beta, cosine of beta. We shall find cosine of gamma. We shall find this much. What will be the answer? We shall check. Already you know that. For one, I will tell you how we can write it. Okay. Now, this is R. This is what is the distance of OA? X is right answer. See, this is X. Because if I extend this, if I extend this line, if this is X axis, so till here we don't know exactly. Therefore, we consider that as a X. Already then it will become X. Now what happens? Cos alpha will be given by cos alpha. Cos alpha is given by cos alpha is given by. What is the formula? Opposite by hypotenuse, adjacent by hypotenuse. X by R vector R. We can call that as X by. We can call that as X by vector R. We can call that as X by vector R. Next, if I go like this, can anybody tell me what can be written for cos beta? We have written for cos alpha, X by vector R. What we can write for cos beta? Can anybody answer? Y by R vector. Same way, we go in one more place like this only. We spoke about only this face. Even this face has got position vector. See, we spoke about this face, 90 degree. See, if I go to this space also, there will be a formation of 90 degree with position vector. So in three sides also, there will be formation. In the same way, we can write as cos alpha. So this can be written as Z by. Clear to you? So here what we will do now? R modulus of vector R is generally we will write as R. Generally written as just we will write as a R. Just we will write as a R. We will write simply not this also. Cap also no need. Just we shall write that as a R. Now it is difficult to mention, no. Therefore, what we shall do, I'll give writing cos alpha is difficult. Therefore, what I am going to do, let me consider this as a L. Let me consider this cos beta as a M. Let me consider cos gamma as a N. See, these are all the direction cosines. These are all direction cosines. Is it clear to you? This L, M, N are called L, M, N are called direction cosines. Direction cosines. Clear to you? So anyhow, L can be written as these are all not there in your vector algebra for some extent, I think so. I didn't check properly. Since I have taught 3D, I know that it will come in 3D. It may come in vector algebra too, but be careful about this. See, how can I write L now? Look at here, my dear students. L value, I'll round figure here. Look at, if I round figure here, this L is equal to X by R vector. But already we said that R vector can be written as small r. Therefore, L can be written as X by R. L can be written as X by R. Next, M can be written as Y by R. Next, Z can be written as Z can be written as, what can be written? Z, L, M, N. N can be written as Z by R. Now we shall see about direction ratios. We shall see. What is direction ratios? Direction cosines are the numbers. Direction cosines. Direction ratios. Direction ratios are numbers. It is a numbers, like it will be like A, B, C. Numbers, it is a numbers A, B, C. Such that, I'll explain you, don't worry. Such that they are proportional to direction. They are proportional to direction cosines. They are proportional to direction cosines. That means to understand the concept of direction ratios, we need to understand the concept of direction cosines. Clear? Next, if I go further in this, what is the direction ratios? What it says? See, directly it gives, like it will be like A by L. A is direction ratio. It will be in proportion. They are saying B by M. It will be B by M, and it will be C by N will be equal to a constant called K. A by L, B by M, and C by N, that will be equal to K. But we know that, just now we have finished one concept. L is X by R. In previous slide we have studied X by R. That implies what actually? That implies X is equal to, I can write as, that means L is equal to X by R, M is equal to Y by R, we shall write. But we know that, understand here guys, it's very simple, but we know that L is X by R. We have studied already. M is equal to Y by R. N is equal to Z by R, correct? Now, I can take X as, X is equal to LR. Y is equal to, I can take that as a MR. I can take Z as, NR. But let me call LR as A. I'll call as A. Okay. Next, let me call MR as B. Let us consider. Next, we shall consider this as a C. We shall consider LR as a, and it is B, and it is, and last one we shall consider as a C. We shall consider. Okay, na? If I consider like that, what happens now? See, now we shall substitute in this. Where and all you are finding the value of the, here A. A can be written as what here? Can anybody tell me now? See, this is known concept. This is not new. This we shall substitute here. Then this I'll call as equation number 1 if you want. Then equation number 1 becomes, what happens here? In the place of A, I can write LR. Is it clear to you? LR by, what is there here? L. LR by L. That is equal to B value. See what we have considered. That is MR. MR by M. MR by M. Last one is NR by, correct? NR by R. I have written. See, this is equal to something like N we consider. Because it is equal to K, it is, we shall consider, generally we shall consider that is equal to N. See, this is direction ratios. This we will call it as a direction ratios. I'll erase this. Relationship among direction cosines direct relationship he will give, guys. What direct relationship he gives, do you know? So he says L square plus M square plus n square always will be equal to 1. Always L square plus m square plus n square, always it will be equal to 1. But you should be knowing what is L. L is, see, in the beginning problem we have done, what is L? L is x by r vector r. M is y by vector r. N is z by vector r. This we have written already in today's class only, beginning class we have written. But we know that even this also we have written. What is the value of the position vector? I said I'll prove you at last. Right? That only. See here, L is equal to value of this R is square root of x square plus y square plus z square. X square plus y square plus z square. Value of the m will be y by square root of. Value is not going to change. Position vector is same here. According to that, so x square plus y square plus z square. Next, if I go for n, so z divided by square root of x square plus y square plus z square, it can be written like. But you may get confusion what are the things are here. So for that sake, we shall write here L, M, N, R are direction cosines, and A, B, C are which is direction ratios, correct? Direction ratios. So LMN are direction cosines, ABC are direction ratios. Therefore, what I am going to write here, what we are going to write here is, see, this can be, this A can be written as L, A by square root of x square plus y square plus z square. In place of x, we will replace with the ABC. Next, m can be written as b by square root of x square plus y square plus z square. N can be written as c by square root of x square plus y square plus z square. Look at here. Here, L, M, N are the direction cosines. A, B, C are direction ratios. This is the relationship among the direction cosines. It may be ratios or it may be cosines. It is like this.